So now let us see that what happens when we transmit a bit stream like 0, 1, 0. The first we have transmitted a 0, then a 1, then a 0. So the first, so 0 is represented by, or I can say the 0 when it reaches the receiver, it looks like this. Negative negative pulse which has its tail spread out in both the direction. So this is the first 0 that we have received. This is the first 0 that we have received. After that, 1 was transmitted. So the receiver will receive 1 after it received the first 0. So see, this is the 1 that it has received. Okay. And after that, one more 0 is transmitted, and the next 0 and this 0 it will receive after 1. So see, this is the second 0 and its position is coming after the position of 1. So what's happening here? See, if I take the region of 1, here only this pulse should be here. We can expect that only this pulse should be staying here, but in reality, in this region where only this pulse should have been existing, 2 more pulse comes into existence. See, this tail of this pulse is extending into the region of 1. Similarly, tail of this pulse is also extended into the region of 1. So that means here one particular pulse, in one particular pulse, if I see the existing region, within that region its neighboring pulses tails are getting inserted like an intruder. I repeat this thing. Here if I see the area or the time of existence of one particular pulse, what due to this tail spreading, what is happening? The neighboring pulses tails is entering into the region where the pulse should have been staying along. So this entering of one pulse into its neighboring pulses, so entering of one pulse into its neighboring pulses, this phenomena is called inter-symbol interference. This phenomena is called inter-symbol interference, or in short ISI. So now, so what is the problem associated if ISI happens? So what problem will practically face if ISI happens? So if I say I am the receiver and I am trying to detect this 1 over here. So if I am the receiver, how I will detect that whether it's a 1 or not? I will sample the voltage over here, okay, and if I see that it is a positive voltage, I'll understand that okay, this is a 1. Whereas if I detect a negative voltage over here, I will say it's a 0. But due to ISI, what is happening? If there was no ISI, what should happen? Only in this region a positive pulse will be existing. So the receiver, when it samples the height of the pulse, it would get a positive pulse, a positive height, and it will say okay, this is a 1. But what's happening? See, due to the tail of 0 has entered in the region, so the tail of the 0, suppose I am sampling the pulse, I am redrawing it over here, redrawing the same thing over here. This is my first 0 and this is my 1 and this is my second 0. So now if I am sampling at this point, the receiver is trying to sample at this point to check the amplitude of this pulse. Not only this amplitude is coming, but apart from that, amplitude of this curve, of this pulse, and also the amplitude of this pulse is also coming into picture. So this is a negative. So this height, if I take the 1 pulse that refers to 1, if this height is positive, on the other hand, the pulse height of these 2 pulses are negative. So this positive height, when it will be getting added to some negative heights, the net height, this height plus this height plus this height, it may become a negative quantity. So that means the pulse that should have been directed as 1, it could be mistakenly directed as 0. That means this is a problem is associated if ISI occurs.